A mid-latitude cyclone is a migrating center of low pressure. It comes along with various fronts, a cold front, a warm front, and an occluded front. Fronts are areas where air masses with different characteristics meet.
The cold front represents a boundary where cold air is replacing warm air. As the cold front moves along, warm air ahead of the front is lifted along the frontal boundary. The rising warm air often condenses into huge thunderstorms that produce heavy rain, strong gusty surface winds, and occasionally hail. As the cold front passes, the wind shifts, temperatures drop, and precipitation usually ends as drier air moves in behind the front.
The cold front advances relatively fast. Cold air is denser than warm air and forces the warm air aloft. Thick clouds develop fast and cause sudden heavy precipitation in unstable conditions.
A warm front represents a boundary where warm air is replacing cold air. The clouds that form along the frontal boundary may extend far out ahead of where the front is touching the Earth's surface. In winter, as the cold front approaches, precipitation may begin as snow, which often changes to sleet or freezing rain, and finally to rain. As the warm front passes, temperatures rise, winds shift, and precipitation usually ends. In the warm air behind the front, scattered clouds often form.
The warm front advances slowly. Warm air pushes the cooler underlying air into a wedge shape and slides up gently unless there is instability. We find a slow development of clouds with slowly increasing rainfall. Clouds typically start with cirrus clouds, thickening to cirrostratus clouds, altostratus, stratus, and finally nimbostratus clouds. The warm front advances slowly and often causes long and light precipitation. The cold front advances fast and often causes short and heavy precipitation. An occluded front occurs when the cold front catches up to the warm front and the warm sector is lifted off the surface. As we will see, an occluded front often marks the end of the life cycle of a mid-latitude cyclone. A mid-latitude cyclone results from two conflicting air masses which meet along a front. It experiences a very characteristic life cycle. Mid-latitude cyclones often start at the polar front, where cold air from the north meets warm air from the south. The warm air from the south is deflected to the right by the Coriolis force, causing westerly winds. Warm air from the north is also deflected to the right through the Coriolis force, causing easterly winds. A slight undulation of this flow can cause a wave, which eventually will cause warm air to migrate northward behind the developing warm front and cold air moving southward behind a developing cold front. A warm front on a weather map is illustrated by a line with red semicircles. A cold front on a weather map is illustrated by a line with blue triangular spikes. At this stage, we have developed counterclockwise cyclonic circulation. A low pressure area forms. Low pressure causes converging winds, clouds, and precipitation. Along the warm front, warm air is lifted, causing also clouds and light rainfall. Along the cold front, warm air is lifted quickly off the ground, causing thick clouds and heavy precipitation. This marks the stage of a mature mid-latitude cyclone. The satellite image shows the warm front with cirrus clouds ahead of it, the cold front with thick clouds, and the center of the low pressure system. You have learned that the cold front migrates faster than the warm front. Therefore, it will eventually catch up with it. When this happens, we get an occlusion, which marks the final phase of the mid-latitude cyclone and leads to its dissipation. The mid-latitude cyclone will affect all regions that are covered by its migrating low-pressure center or its migrating fronts. A location which experiences an approaching warm front will see wind directions turn to southeast, temperatures increase, and the cloud cover thickening and lowering. The area between the warm front and the cold front is called the warm sector. Within the warm sector, winds will turn to southwest. We will see relatively high temperature and a clear sky. And finally, an area that is affected by an approaching cold front will see winds turn to northwest, low temperatures and humidity, cumulus clouds, and possibly heavy rain. Here is another illustration that shows how the weather changes as a mid-latitude cyclone crosses the United States. On the right, you see a cross-section from A to B. At this stage, the mid-latitude cyclone is fully developed. We see a warm front with cloud cover, a cold front with cloud cover, and the center, the low-pressure center of the mid-latitude cyclone. Later we observe that the low-pressure center and the fronts have migrated. The cold front has partially caught up to the warm front, so we see the beginning of an occlusion. Even later, the low-pressure center and the fronts have migrated even further eastward. The system is almost fully occluded by now. Typical paths of the mid-latitude cyclones in the United States are illustrated here. We see typical paths of the Alberta Clipper, the Colorado Low, the Gulf Low, or the Hatteras Low.